Number 9 from the Proving Parallelograms homework. Must quad EFGH be a parallelogram? Can it be a parallelogram? Explain. All right, so what do we know about number 9? Number 9, I see that we are given two angles. What do you know about those two angles? 115, 65. They are supplementary, right? They add up to 180. Now, when same side interior angles are being supplementary, we know we have a pair of parallel lines on our hands. Now, which lines are the parallel ones? This is the parallel line, and this is the transversal. Cool. So, I don't think I can add anything else to my picture. I have one pair of opposite sides parallel. I have one pair of consecutive supplementary angles, but there's nothing else I can add to my picture. Nothing else. So, I'm kind of stuck. Must it be a parallelogram? Absolutely not. Could it be a parallelogram? Could this angle be 65 and the other one be 115? Sure it could. Can it be a parallelogram? Yes. So when you get no to the must and you get yes to the can, then the answer is sometimes. That shape would sometimes be a parallelogram and sometimes not. Number 13. Now you have to keep in mind what the question is here. Decide if you have enough information to determine it's a parallelogram. Not decide are those markings correct, because I agree. At number 13, vertical angles are congruent. That's awesome. They're always congruent. That is true. But do vertical angles make a parallelogram? I mean, I could draw a counterexample, and that's why we learn about counterexamples, so you can learn to think about these things. I could draw a counterexample where vertical angles are congruent. See, I have those awesome vertical angles, but I connect the dots, and oh my goodness, that's not a parallelogram. So vertical angles being congruent doesn't make the opposite sides parallel at all. It just means that two lines crossed. That's all you need to have vertical angles, two lines crossing. And two lines crossing will not always make a parallelogram. So that one is definitely no. Now looking at number 15. When you look at your picture, I mean, you can add tick marks here if you really want to. 7 is equal to 7. When you don't know where else to go in your picture, when you're like, I don't know what else I'm allowed to add, I'm not sure if I can find the missing angles, if you don't know what else to do, then just go ahead and draw yourself a diagonal. Because if you draw a diagonal, you can play the congruent triangle game. And you can say, hey, are those two triangles congruent? Because if they are, the answer is yes. If they're not, the answer is no. So take a look at triangle 1 and triangle 2. If I were trying to prove them congruent, I could add tick marks, reflexive property, right? And then I've got angle, side, side. Angle, side, side. Uh-oh, that one did not prove triangles guilty of being congruent. Therefore, I have some great information on 15, but I just do not have enough information to conclude that it's a parallelogram. 16. Oh my goodness, what do we have here? We have alternate interior angles being congruent. They are doing what they're supposed to do. So I taught you to draw the letter Z, and you are allowed to add arrows. Alternate interior angles being congruent gives you permission to add arrows showing that the lines are parallel. Oh my goodness, I can do it here too. And I am done. The problem is solved. That both pairs of opposite sides are parallel. That's the definition of parallelogram. So I use those alternate interior angles. Could you have looked at the triangles and done angle, side, angle? Yes, you could have done that, absolutely. 19, we have to read a proof that's already written, and we have to find out where the error is. Okay, given, I can't see any errors there. You say that E is the midpoint, and then you say that the segments on either side are congruent. Definition of midpoint, looking good. AED and CEB. Okay, those are vertical angles. Vertical angles are congruent. Very good. The two triangles are congruent by angle, side, angle. Let's see. Yep, because here's our angle, here's our side, and here's our angle. So that's good. AD is congruent to CB. AD is congruent to CB. CP, CTC. Very good. Okay, I'm going to have to scroll down. All right, so there's the mistake right here. It happens at the very end. The proof is great. All the way down, the proof is great. What did they do wrong? If a pair, look at that. If a pair of opposite sides are congruent, then the quadrilateral is a parallelogram. That's just not enough information. We learned yesterday that both pairs of opposite sides have to be congruent. So that is what is wrong with the proof. You have to have both pairs of opposite sides congruent to be a parallelogram.